Welcome back, pre-calculus. I hope you all are well. Today's objective is going to be to simplify log expressions. I've got the checklist on the screen. You know what to do from here. All right, quick warm-up. You can do this in your notebook or just do them in your head. See if you can get these exponential expressions simplified for me, and then go ahead and hit continue when you are ready to check your answers. All right, I've got the answers on the screen. Remember that a fractional exponent means to take the root, and a negative exponent brings your base to the denominator. And we've got both a negative and a fraction. This means take the square root of 9, which is 3, and then put 3 in the denominator. So take the reciprocal of 3. All right, so we are going to start with a puzzle. So look at, I've got the puzzles filled in for A and B. And force pause on the screen. Try to see if you can figure out the answers for C and D. Hit continue when you are ready to check your answers. All right, so hopefully you got 3 for C and 2 for D, right? Because our little puzzle here is basically this base to what power is 27, right? So 3 to the third power is 27. So this number to this power equals that number, right? Similarly here, we've got 4 to what power is 16? Well, 4 to the second power is equal to 16. So basically, our little puzzle was that B to the y power needs to equal x, right? So let's try some more. All right, and force pause on your screen, try these. So tell me what the 3 to what power is 9, etc. Hit continue when you're ready to check your answers. All right, answers are on the screen. You can go ahead and pause if you need to change anything. Again, keep in mind that here we've got 4 to the 1/2 power is 2, right? Because the 1/2 power means to square root. And here we have 2 to the negative 1 power is 1 over 2, which is a true statement because the negative 1 power drops that 2 to the denominator. So here is the secret, is that mathematicians insist on calling this power function not a power, but a logarithm, okay? And so that's all a log is. It's revealing the exponent or the power of that function. So we've been writing it like this, like power base b of x is y. Mathematicians will write it like this, log base b of x is y, which is the same as b to the y equals x. So I'm going to force pause on your screen, and I would like for you to write these two statements here. All right, can you also write these restrictions that x and b both have to be positive? So I'm going to put greater than 0. I also can't have that b is 1, otherwise I don't get sort of this inverse of an exponential. I just get this constant function. Force pause on your screen. Try example 1 for me now and do this just like you were doing the power functions, just we're calling this log. So this just means 3 to what power is 9, and that is 2. All right, you try the other 3. Hit continue when you're ready to check your answer. So these should look similar to a little while ago, but these are our answers for example 1. Go ahead and pause and change anything if you need to. All right, so would you go ahead and write this first, let me do this first equation, and the left side is going to represent exponential form, the right side is going to represent log form. I just want you to remember that you're always going to start with your base and then go to your answer, okay, and then come back to your exponent. So if I want to go to log form, we're going to first start by writing log. Now whatever your base was here becomes your basement here, so log base 2, now switch sides, of 64 equals, and remember that what's equal to must be your power, right? That's what logs reveal, is the power, okay? So these two are the same, just two different ways to write them, okay? All right, will you write this for me? 4 to the 1 equals 4. Let's write this in log form. So if I'm going to log form, I first have to start with log. Now whatever your base was here, what you have to a power, that's your base or your basement here. So log base 4, switch sides, of 4 equals, switch sides again, 1. Remember here, this should always be your exponent on this side. So whatever the exponent was here is what should be isolated over here, okay? And this is read as log base 4 of 4 equals 1. All right, let's try going the other way. So I go ahead and write log base 5 of 1 equals 0. And now let's convert. So start with your basement. That becomes your base. Now switch sides. That becomes your exponent. Equals, and this is called your argument, and that's your answer here. Okay, so notice again, whatever my exponent is in exponential form should be what's isolated, what my answer is in log form. All right, you try this next one, hit continue when you're ready to check your answer. So we should get 5 to the negative 2 equals 0.04, which is a true statement because 5 to the negative 2 is 1 over 25, which is 0.04. All right, try this one. 3 to the x equals 81. Hit continue when you're ready to check your answer. We should have gotten log base 3 of 81 equals x. Again, remember, whatever your exponent is here should be what's by itself in log form. All right, try this last one for me. Convert to exponential form. So we should get question mark to the heart equals star. Remember, whatever is by itself in log form becomes your exponent in exponential form. So there's a very special number that occurs a lot when we are talking about logarithms, and that number is found by taking the limit of this expression. So can you write this in your notes? The limit as x approaches infinity of the quantity 1 plus 1 over x all to the x. And we're going to take a look at Desmos and see if we can figure out what this limit is. So I've graphed 1 plus 1 over x all to the x, and what I'm going to do is slide this blue dot, and the blue dot's going to go farther and farther to the right, so we're going to see if my y values here are approaching any certain value. Let me kind of slow this down a little bit. So maybe you can see there's certainly we're getting larger and larger, but very, very slowly, right? And there certainly seems to be some sort of limit here, some kind of horizontal asymptote. Do we know what this blue dot or blue number is approaching there? So this is approaching the line y equals e, and e, if you can look right here, is it's a transcendental number. It's 2.718 ... goes on forever and ever. So very similar to pi. Another similar thing about e and pi is that they both round, if you're rounding to the nearest integer, they both round to 3, okay? So they're both real close to 3, but e is this 2.718 ... So I'd like for you to write that this is equal to the number e, which is approximately 2.718, okay? But it goes on forever. You just need to know that this is close to 3. This is called Euler's constant E. We spell the mathematician's name like this, but it's pronounced Euler. So that's why we use the lowercase letter e to honor Mr. Euler. All right, so there are 2 log bases that we use the most. The first one is log base 10. This is called the common log. So I'd like for you to, I'm going to force pause on your screen. Go ahead and write what I have in your notes. All right, so if you see that this is just blank, then there's an understood 10 there. And we do this, we do understood numbers all the time in math, right? Like if I just do square root of x, there's an understood 2. Right here. If I just do x, there's an understood 1 right here. So we do, we leave off the common numerical values quite often when we're looking at certain algebraic functions. Log is no different, okay? So if you don't see a base written in, it's understood to be base 10, all right? The other really common log is base e, and e is about what number? E is about 3, 2.718 ... So when you see base e, sometimes you'll see it written log base e, but much more often you'll see it written like this. So that's an ln, okay? So when you see ln, that means the exact same thing as log base e, and e is about what number? E is about 3. I don't want that to be super mysterious or anything. It's just a number, okay? It's not a variable. So this is called the natural log. Unfortunately, we write ln instead of nl, but natural log or log natural. All right, can you copy what I have for example 2? And we'll do these together. Okay, we are back, so let's just do these one at a time. So I've got ln of e. So what is the understood base there? The understood base is e, so let's write it like this, okay? Now, what does the log give us? The log gives us the power, so this means e to what power is e? Well, that is 1, right? Let's try this one. So let's rewrite a couple things. I don't see a base, so what is the understood base? The understood base is 10, so let's write that. Now let's write this part, that 9th root of 10. Can we write that as 10 to the what? The 1/9, okay? Now remember, what does log give us? Log gives us the power, so this means 10 to what power is 10 to the 1/9? Well, 10 to the 1/9 power is 10 to the 1/9. All right, let's try this one. Again, let's rewrite. ln means what log base? Log base e. Okay, now let's rewrite this piece. The 4th root of e to the 3rd can be rewritten as e to the what? E to the 3/4 power, right? So again, log gives us what? Log gives us power, but notice that your base in both cases here is the same. So you're going to get this nice cancellation. See how we keep getting this nice cancellation? So e to what power is e to the 3/4? Well, the power is 3/4. All right. Can you do this without rewriting? So remember, this is what base? Base e. So this means e to what power is 1 over e to the 8th. So what is this? This is rewritten as e to what power? The -8th power, right? Remember, log just gives us the exponent, the power. All right, take a look at this one. Can you simplify this at all? Is this a little bit cumbersome maybe? So what we could do here, should we just call the answer x for now, and then can we convert to log form, okay? So if I convert to log form, this would be log, and what my base is here becomes my basement, so that's log base 8. Switch sides to get what's called the argument, so log base 8 of x equals, and then remember the power, the exponent, is your answer here. So that's just log base 8 of 6. So what does x have to equal? X must equal 6, right? So 6 is my answer here. So what I want you to see is that when you've got a base raised to a log with the same base, those essentially cancel. And that's your answer, okay? What if I take log of -2, okay? So shall we do the same thing here? Let's let this be x, and let's convert. So what is my understood base here? Understood base is 10. My power is x equals -2. Well, can I ever have 10 to some power and get it to be -2? No matter what power I choose here, I can never get 10 to a power to be -2. So this is no solution. If you look back at the restrictions we wrote for x, for our argument, remember your argument has to be positive. So you cannot take the log of a negative number. So if you have log of a negative, there's just no solution. All right, let's conclude by generalizing kind of what we just saw. So can you, and force pause on your screen, can you go ahead and copy what I have? Okay, so if we have log base b of b to the x, see how you've got a log base and an exponential, and you've got the same base value, b. Those are going to cancel, and you will just be left with x, okay? The reason is if you can convert this to exponential form, so start with your basement, that becomes your b value. Okay, that becomes your base. Switch sides to get your exponent equals, and then your argument is your answer, and this is a true statement, right? Okay, similarly here, you've got an exponential and a log with the same base, so those are going to cancel, and again, you'll just be left with x. The way we can verify is convert this to a log statement. So I'm going to start with log. whatever the base is here becomes my basement. Switch sides to get your argument, equals, and the exponent is my answer. And this as well is a true statement, right? So these are the special properties of logs. Basically, if you've got a log and an exponential right next to each other with the same base, they'll cancel, and you'll just be left with this x piece here or here. All right, you all, that's what I have for today. I'll see you all next time.